Practice can feel productive, but memory can still stay weak. Richard Feynman understood this problem early. You begin to notice a pattern in many skills. You repeat the same thing again and again. You spend time. You feel busy. Yet the next day you forget steps, or you feel confused again. This happens because practice can be shallow. The brain can repeat actions while dropping meaning. Feynman explained that practice must include understanding. If you do not know what each step does, you are just copying motion. Copying motion does not build a strong map in your mind. Learning science supports this with the forgetting curve. Memory drops fast when practice does not create clear meaning. Shallow practice also creates weak recall because nothing is tied together. Practice must include understanding to create memory. Practice works best when it stays connected to thinking. Feynman did not treat practice as mindless repetition. He treated it as a way to test what he understood. When he practiced, he paid attention to the reason behind each move. He wanted to know what causes what. He wanted to know what changes the result. You begin to see the difference between two types of practice. One type is just doing. The other type is doing while checking. In the second type, you watch your steps. You notice mistakes. You make small changes. This is how practice becomes learning. Research on deliberate practice supports this. Strong skill grows when practice has clear goals, full attention, and feedback. Time alone is not enough. Practice works when thinking stays active. Confusion repeats when practice repeats errors. You begin to see how this happens in daily learning. You do a task the wrong way. You do it again. It feels easier each time because your body learns the pattern. But the pattern is wrong. Soon you feel confident, not because you are correct, but because you are familiar with the mistake. Feynman avoided blind repetition for this reason. He wanted errors to show up quickly. He did not want practice to hide them. He would stop and ask what went wrong. He would change the step and test again. Learning psychology explains this as error reinforcement. If feedback is missing or ignored, the brain strengthens whatever it repeats. It does not care if the pattern is correct. If you practice while confused, you build a stable form of confusion. That makes later learning harder because you must unlearn first. Unclear practice creates lasting confusion. Clear goals make practice useful and clean. You begin to notice that practice becomes messy when the goal is vague. You sit down to practice more. You jump between parts. You try many things. You finish tired, but you are not sure what improved. Feynman practiced with a clear target. He did not try to improve everything at once. He chose one specific thing to get better. He made the outcome clear before starting. This kept attention sharp and made progress measurable. Research on goal-directed learning supports this. A clear goal directs attention and reduces distraction. Before a session, write one goal in one sentence. Make it specific. Practice only for that goal. At the end, check if the goal improved. If it did not, adjust the method. Clear goals shape effective practice. Small units make learning stable and clear. You begin to see that complex skills are made of smaller skills. If you practice the whole thing at full speed, errors stay hidden. The mind cannot track what is happening. The body may move, but understanding stays weak. Feynman practiced small parts before full systems. He wanted each part to be clear. Then he combined parts after the base was stable. Cognitive psychology supports this through chunking. The brain learns complex actions by grouping small pieces into chunks. You begin to see a practical approach. Split the skill into steps. Practice one step until it is clean. Then add the next. If a mistake appears, return to the smallest step that contains the error. Small practice units build strong memory. Explanation turns practice into understanding. Feynman explained ideas while working because explanation forces clarity. When you explain what you are doing, you must name the goal of each step. You must state what the step changes. You must state what you expect to happen next. You begin to see how to use this during practice. Before a step, say what it is for. While doing it, keep attention on the key point. Afterward, state what happened and why. Research on self-explanation supports this. Explaining your actions deepens processing and exposes errors faster. Simple words keep the thinking honest. Explanation also improves recall because you remember reasons, not just motions. Explanation turns practice into memory. Practice improves only when results are checked. Feynman trusted feedback more than effort. He did not assume time spent meant progress. He tested whether practice produced the result he expected. If it did not, he changed the approach. Without feedback, practice drifts. You may practice the wrong thing or repeat the wrong form. Learning science explains this through feedback loops. You try, get a result, compare it to the goal, and adjust. After a short practice block, check the result with a clear measure. If it gets worse, slow down and change one step. If it improves, keep that change. Feedback keeps practice accurate. Slow practice makes errors visible. You begin to notice that speed can hide mistakes. When you go fast, you skip checks and rely on habit. The result may look fine, but the process is weak. Feynman slowed down to see each step clearly. Slow practice gives you time to notice small errors and correct them early. Research on speed and accuracy supports this. Accuracy improves when speed slows down. The correct order is simple. Make it correct first. Make it consistent next. Then make it faster. Slow practice builds clear understanding. Practice becomes powerful when it strengthens your mental model. Feynman used practice to improve his understanding of cause and effect. He wanted to know which changes matter and which do not. A mental model tells you what to expect and what a mistake means. Without a model, practice becomes copying. Research shows people learn better when they have a clear internal structure of how a skill works. After each session, write a short cause and effect note in plain words. Over time, this builds a strong model. Practice strengthens mental models. Efficient practice focuses on weak points, not full repeats. Feynman reviewed what failed. He located the breakpoint and worked on that one part. This saves time and reduces frustration. Full repeats hide weak steps. Targeted review makes the weak step appear often, which is how it changes. Practice the full skill once to find what breaks. Isolate that part. Do short cycles with feedback. Then test the full skill again. Targeted review sharpens memory. Clear practice becomes strong when it becomes consistent. Feynman treated learning as daily work. He used small sessions, clear goals, explanation, and feedback. Over time, confusion dropped because errors were corrected early. Daily practice does not need to be long. It needs to be clear. 10 to 20 minutes of focused practice is stronger than hours of distraction. The brain changes through repeated clear use. Practice is not just time spent. It is a method you repeat. When the method is clear, memory becomes stable and confusion becomes rare. Clear daily practice creates lasting memory.